Welcome to a new webcast of KEB's series Tech Tuesday. Our topic today is high power wind turbines. As you can see in the back, we are in a production hall where the P6 pitch inverter is manufactured. Today my guests are Dirk Ehlert and Sebastian Eike from the application team Wind. So, would you please introduce shortly yourself to the audience? Why exactly are you here today?
Of course, I can do that, Christine. Thank you for the short introduction. Yeah, well, I'm here because I am almost 20 years now at KEB, and roughly 10 years I'm working in the renewable energy group and selling high performance products for the renewable energy market. And I am the key account manager for our customers in Europe and North and South America.
Yeah, I'm the newest member of the team. I came to KEB roughly one year ago. Yeah, can say that. And this is my first job after graduation. And yeah, when applying here, I soon found common ground with KEB because I did my thesis in the area of, or in the field of energy generation using wind turbines. So with this background, I soon found a good fit here, and I try to support all the group members in their tasks, but especially Ludger Brohl, our product manager, and I will try Sebastian and Frederick to support with their customer projects.
Thank you. So, Sebastian, my first question is, wind turbines are getting bigger, and what does KEB offer for this?
Yeah, well, you can say the same like for smaller turbines as well. So we can start at the pitch inverter and then pitch motors, pitch brakes, and main strokes as an example. You see that we are not supplying whole systems or cabinets. We are just supplying key components for our customers. What we have learned in the past in the cooperation with our customers is that our customers would like to buy just the key components and would like to do the manufacturing of the pitch cabinet themselves. So that is also the reason why KEB is just supplying key components and not cabinets. And in addition to pitch solutions, we also can offer a solution for the yaw system or just standard frequency inverters for, as an example, fans.
And what are the advantages of electrical solutions compared to hydraulic ones?
Yeah, that question is really not easy to answer because both solutions have their advantages and disadvantages. But when I look in regards to the environmental protection, and this is exactly the reason why wind turbines are used for generating power, then I would say that the electrical pitch system has the advantage because you don't need hydraulic oil for your pitch system. And thus you also don't need to check the leak thickness as an example, and also you don't need to change hydraulic oil. So from this regard, I would say the electrical pitch system has the advantage that you have lower maintenance and the follow-up costs are also lower.
Mm-hmm. Okay. And Dirk, what are the special requirements for pitch drives?
Okay. Yeah, first you must know the pitch system is safety relevant for the operation of the whole turbine. In case of any failure, if it's component failure or grid failure, the turbine has to reach its safe position, the so-called feeder position, where the blades are aligned within the wind. And the pitch system supports or will do the safety run and do the movement after a case of failure. And this movement is safety relevant and requires functional safety, what we also can offer with our pitch system. This is one big requirement. Next to this, we have environmental requirements. our wind turbines are built up in places no standard or no common industrial inverter or industrial drive will be installed. Like we have very high heights. Our drive can be installed up to 3,000 meters heights. We have dealing our drives with high humidity or very cold temperatures when we look at turbines in Canada maybe. Plus we have a lot of vibration in our tower, the hub of the wind turbine, which also stresses our drive. But besides all that, we can say we are providing a very robust system, which is also very important because maintenance is really cost intensive and time consuming. So we have to give a system which is very reliable and has a low failure rate. And I think we can do this. This has proven itself with the 1819 P6 over the last few years. And this is also the requirements we set when developing the 23 P6.
So Sebastian, what is particularly important or was important for the development of the 23 P6?
Yeah, the goal was to develop a pitch inverter for turbine sizes 10 megawatt and higher. And that of course requires high current or rated current and high overcurrent capability. Of course it must be robust, but on the other hand it is also necessary that such a device is not too big and also not too heavy. And I think our R&D here did a great job, and we found a very good compromise between all of these aspects with 120 amps rated current and 350 amps overcurrent, a total weight of 45 kilograms, and as you can see, a really robust, compact design. I think we did a really great job, and otherwise the 23P6 also has the same features like the little brother, the 19P6, like an internal PLC, an integrated high-performance braking resistor, or as Dirk already said, the capability to withstand low temperatures as well as high temperatures, so the temperature range from minus 30 degrees to plus 60 degrees is also very impressive.
And Dirk, what is special about the 19P6?
Speciality of the drive starts with the development phase of our 1819 P6. We developed it in strong communication with the customer, so it's really a good fit for this particular application. And by making this special drive, we were able to make a very compact drive where a lot of components are combined in one housing, and so our P6 only takes up a small construction place. Furthermore, we have a wide voltage range from the grid side our drive has to deal with, and he's also very capable of doing it. And all in all, I think we can say we did a pretty minimalistic approach to get the application running.
And whether offshore or onshore, what role does remote access play?
We already spoke about the accessibility of the turbine, that it takes a huge effort to go into the turbine, and remote control and remote access helps you with this topic. The common maintenance will never be replaced totally with remote access, but it can help you with your maintenance and make it more efficient. Like if you have an issue or any problem occurring on the drive, you can remote access the drive and get a first impression what's wrong maybe, and then plan your maintenance accordingly. Like what spare parts to bring, who should do the maintenance, what is required. Also in our Corona times, this helps us of course a lot. We are sitting here in Bartrup in a lockdown in Germany currently, and so traveling is very hard. So we can help the local maintenance guys on site. When they do maintenance, we can make up a conference call and also put us on the drive so we can see what's wrong there and help the guys on the site.
Okay. And what analysis options are available for KEB pitch inverters?
Yeah, Christine, as you can imagine, especially for the development and prototype phase, it is very important that the turbine manufacturer and the pitch supplier, as an example, work really close together. The turbine manufacturer must be able to check whether its simulated data fits also the reality. And especially for that, KEB has integrated in the software a really powerful data logger and a scope function. And with these two solutions, let's call it solutions, our customers are able to record values and do an analysis. And that helps our customers to prove that the turbine is always running well in all conditions. And of course, we don't leave our customers alone. We have a really great team who assist our customers in doing that. It starts, of course, with Dirk here, but we also have two other guys, our product manager, Mr. Ludger Brohl, and our PLC programming specialist, Walter Pieper, are on hand to help us here as well.
Yeah. Let me pick up at that point where you mentioned the data logger, because this is really a useful multi-tool we have at hand for analyzing all kinds of issues and problems we have on the turbine maybe. Because our data logger is super customizable and you can track all kinds of parameters we have in the drive, and you can customize which parameters you need to track for this particular problem and change that every time. Also, the data logger records a certain amount of time its data because there's not enough memory on the drive, of course, to record independently. So we can start the recording with a trigger event. And this trigger event can also be customized, set to every event you want, like, okay. Plus, for analyzing possibilities, we have the error history in every KEB drive. So when an error occurred, the specific error is saved according to its timestamp when the error occurred. So when analyzing the drive after a failure, you get an idea what has happened before. Plus, we have developed, especially Walter Pieper developed function libraries. And we have the possibility to monitor our different functions of the system. For example, use the YAW library. We have the function block gearbox broken. It's so-called, you can it checks if the gearbox of the according motor is broken. And if so, it will tell the turbine controller that we have a problem here, and the customer and it can react accordingly in its program. So what to take from here, I think it's important. Our drive can not only deliver information on the drive itself, but from the whole drive system, also the motor.
Yeah, so we often speak about a pitch system. You already mentioned it. And this also includes motors. What does KEB offer in this area?
Of course, we also offer motors, and especially also the design of the motors, which is different for each customer, because for every turbine the blade geometry and the required speeds change. So we are doing a motor design for the customer which fits its turbine construction. And when we have the chance to design a motor, it comes to choosing a technology or topology of motors, and we like to recommend synchronous motors for the pitch application. And this has some advantages, like first to mention, the synchronous motors only take up less construction place than other motors maybe, whilst they are very efficient. They can offer a wide torque range, which is also very interesting for the pitch application. Plus, we have the possibility that we can create a fast control response with the pitch synchronous motors. In case you have on a turbine or in newer turbine generations, they want to do pitch adjustments within one revolution of the rotor. So fast responses of the motor also help in this area. Yeah, our motors are especially coated for offshore applications where it's exposed to seawater, and we offer special coatings for that as well. Also, one point to add: the brake in a the motor in a pitch application comes always with a brake, and we at KEB also provide our own brakes, especially designed for pitch applications. But I think our guys in the mechanical department can say a little bit more about that.
Yes, so I heard the keyword brakes. I would like to involve a colleague from the department, clutches and brakes, but due to the corona situation, we will talk to him separately and then we come back again. Yeah, hello Simon. Thank you that you have come here today. I talked to the colleagues about pitch systems, including pitch inverters and motors. And my first question for you is, where are KEB's options for stabilizing rotor blades in windy conditions?
Yeah, KEB's spring-applied brakes are used in pitch systems which are responsible to hold the position of the blades stable according to the wind intensity, and especially to hold the safety position of the blades in case of an emergency. KEB is a producer of spring-applied brakes since the beginning of wind turbine production. And due to this long experience, we have an optimized brake for heavy applications with a rugged design.
And what type of brakes are installed in the pitch systems?
Yeah. We supply spring-applied brakes which are installed inside the motor, and due to this they are protected through the motor housing. The second solution is an external mounted brake which has an own protection class IP65.
And what is the advantage KEB can give its customers to get brake, motor and inverter from one source?
The big advantage our customers have is that the dimensions and the technical data from our brake is adapted on the inverter. That means that the coil is designed on the inverter to reach the highest torque in reduced space. And at this place, we only want to indicate that our brake has the possibility to be equipped with a micro switch to monitor the wear and to measure the temperature with an PTC sensor. For more detailed information, I want to suggest you to see our video we have made on the last Tech Tuesday, how to monitor a brake intelligent. Thank you.
Thank you, Simon, that you answered my questions. And now we will switch back to the colleagues for the last question. Okay, here we are again. So now we have spoken intensively about the KEB system. And finally, just a request for a short statement. Are there any wishes for the future in the wind energy in general?
Yeah, wishes, maybe just a short statement from my side. I think we all can agree that we must react on the climate change and that renewable energy is one of the important solutions to that. And within the renewable energy, the wind or energy production with wind turbines will have a really big share. And I think what we were able, or hopefully were able to explain here to our customers and potential customers is that KEB has great technologies for that application, and we are really looking forward to help our customers in improving their turbine output with our proven technologies.
Yeah, wishes we do have a lot, of course, but I think it would be more helpful to say what we think, what we can expect in the wind sector in the future, or in the next years probably. And when looking at Germany in particular, we see that the approval processes for new turbine sites are getting longer. This is due to local residents are more willingly to complain against new turbines, and more assessments are needed to certify a turbine place. But on the other hand, we have the repowering of old turbines. So all in all, I think we can expect a growth on the onshore sector. When looking at the offshore sector, I think we will see a bigger growth. All in all, when looking at the overall installed capacity, only 5% of this is offshore so far. So we at KEB expect this percentage to rise, and thus a growth in the offshore sector. Yeah, I think we're ready for that.
Okay, thank you that you were here today. And we've learned from the component to the solution, including consulting. KEB therefore offers a lot for its customers, a complete package from one single source, I've learned. And if you have any questions, do not hesitate to contact us, for example, via email. Our address is webinar@keb.de. And thank you for watching, and we would be pleased if you switch on again.
Thank you. Thank you very much.